Okay. We're live. Now, what we're going to do first, guys, is give two examples of a right angled triangle with all three sides of interior lengths 5, 12, and 13. All three sides of interior length 5, 12, 13. Does that just mean it wants me to make a triangle that's, oh, I get you. The longest side has to be what, guys? 13. The other side has to be 5 and 12. You can have it the opposite way around. You have the 12 on the bottom, the 5 on the top, doesn't matter. How do I know this is definitely a right angled triangle? Yeah, the longest side squared will equal the other two sides squared and added together. 169 will equal 144 plus 25. And then you'll get 169 equals 169. This proves it's a right angled triangle. Everybody cool with that? You do the same thing for the next question. You go, okay, which one is the longest side? I reckon it's the root 41. Would you guys? Root 41 is the longest side. It has to be the hypotenuse. The other two can go anywhere. I can put 5 here, 4 there. Or I could put 5 on the bottom and 4 up here. It doesn't matter. Once again, I need to check that it is in fact a right angled triangle. How do I check that this is a right angled triangle? Pythagoras' theorem. And all of a sudden, we realize that that's 25 plus 16. That's 41. Root 41 squared is 41. 41 equals 41. They're both right angled triangles and they both have those lengths. Everybody cool?
Yeah.
Any questions? Alright. Now, this one. Label the angle B. Well, that's the adjacent and that's the hypotenuse. So that's 5 has to be hypotenuse, 3 has to be the adjacent. What does that make X? Opposite. Which angle am I talking about? The black one or the blue one? Blue. Blue one's got to be angle B. Any questions? We're good. Now, next thing, find the value of X. How do we find the value of X? Yes. Pythagoras' theorem, the longest side squared is 5 squared equals the shorter side squared and added together. 25 equals 9 equals X squared. Riveting stuff. 25 take away 9 is 16. 16 equals X squared. Oh, and what's next? Square root. X equals 4. Absolutely amazing. Now, can we move on? Yes. No. So if you guys did this, if you said X squared equals 3 squared plus 5 squared, the problem with that is that it has to be the longest side. It's not the biggest number. It's the visual longest side. Joe.
And back boxes B is the other angle.
It's great. Backbook's wrong. Okay, let's move on. Now, let's go. This is Pythagoras' theorem. Pythagoras' theorem only works when it's a right angled triangle. This means it balances. Now, what we learned the other day is that when A is obtuse, what happens? The angle's over 90. Now, we know for this triangle, it's going to be A squared is greater than B squared plus C squared. Purely because if you had a right angled triangle, that's where it stopped, wouldn't it? But it's longer. You can see that the hypotenuse has been made longer, so it's no longer a right angled triangle. This means that A squared will be bigger than B squared plus C squared. Everybody alright with that? Not much else you can do. Just have to write that. You have to write that down. You can see from this triangle that angle A is obtuse. Because angle A is obtuse, this means that the length of the largest side is longer than the hypotenuse would be. Therefore, it's an angle bigger than 90 degrees. Everybody okay with that? Great. Move on. This one. Okay. Danny, sign. What's the rhyme we learnt off?
So, Katoa.
Yeah, good man. Okay. Now, first things first. What side is the 7 and what side is the 25?
The 7 is the opposite,
Yes.
and the 24 is hypotenuse.
Great. Can we figure out what this is?
Yeah.
The x value. Go on, how do we figure that out? Pythagoras' theorem. The longest side squared equals the other two sides squared and added together.
Oh yeah.
So how do we do that?
25 squared
Yeah.
equals 7 squared plus x.
25 squared equals 7 squared plus x squared, yeah. 625 equals 49 plus x squared. What's 625 take away 49?
76
576
equals x.
is it 24?
Yeah.
Okay. X equals 24. So, what does that mean about cos theta and tan theta? So if that's 24, what can we say cos theta is? Heyman?
24, 25.
Yes. James, what can we say tan theta is? Thomas,
7 over 24.
the opposite is 7, the adjacent is 24. Now, finally, see this cos squared and sine squared business? That basically means whatever cos is, square it. Whatever sine is, square it. It's a show that question. What does a show that question mean? Has to equal 1. So what do I need to put in here? What's cos theta? 24 over 25? Yeah, exactly. 24 over 25. And what's the other one? 7 over 7 over 25 actually, as it turns out, because you're actually using sine. Now you're going to put them into your calculator, add them both together, and you'll find out that you'll get 1 equals 1. This shows that the question balances and it works. Okay, anybody got any questions for me? Tom, oh sorry, Joe. Yes, Joe. Now, move on. Okay. Next question. Oh, this one looks reasonably difficult, but it's actually not so bad. Okay. What's sine theta? Sine theta, guys? For this triangle. Opposite over hypotenuse. Come on. Okay, cos theta, please. Alright, and finally, tan theta? 4 over 3. Verify that sine theta divided by cos theta. What's sine theta? 4 over 5, and we're going to divide that by 3 over 5, and we proved that that equals 4 over 3. Okay, get out your calculator, put 4/5 divided by 3/5. Now I'll pause this and get the calculator out. You can do this. The first way is you just press the fraction button once, press it again, and what did I say you're going to do? 4 over 5 divided by, and then over 3 over 5. Those of you that are going to be pretty amazing at maths, you guys will know how to do this without the calculator, and here's how you do it without the calculator. You get the 3 over 5 on the bottom, and what you do? You bring it up to the top and turn it upside down. So you bring this and turn it upside down. Then the 5's cancel, leaving you 4 over 3. Okay? If you have any inclinations doing really well in maths, you should be able to do it without the calculator. Is that alright? And then obviously check the calculator to make sure you did it right. Okay?
Can you still do it if you can't cross out any number?
Yeah, you just end up multiplying them. So I think what Danny's asked me there is if I had something like 3 7s divided by 4 over 8.
Yeah.
I bring over 4 over 8 and it turns into 8 over 4. And that's just going to be 24 over 28. And then I can break it up from there. Alright lads, next thing. We're asked to evaluate sine theta times tan theta over cos theta. So here's what we're going to do. Square roots. Whatever sine theta is, whatever tan theta is, divided by whatever cos theta is. Let's throw it all in the calculator. So 4 over 5 times 4 over 3 equal over 3 over 5. Okay, I'm going to do this without the calculator, right? Here's what I'm going to do. 4 times 4? 3 times 5?
15.
16 over 15 divided by 3 over 5. What did I say you can do with that 3 over 5?
3 opens with it.
5 over
3.
3. Okay. 5 into 5 once, 5 into 15.
3 times.
16 divided by 3 times 3? 9. 16 over 9. What's the square root of 16?
4.
What's the square root of 9?
3.
3. And we're done. Okay, that took